All right, we're going to talk a little bit about the lab that we did on Friday. Now, it went well for most of you, at least performing the lab part did. I don't know about filling in your table quite yet. And then some of you, especially 7th period and 6th period, didn't get to do it or to finish it. Now, remember, it's your responsibility to come in sometime next week before or after school, with the exception of Wednesday afternoon, to do the lab. That being said, I'm going to walk you through it real quick. So, this is a picture of the lab setup. This guy is a mass hanger. So for the mass hanger, we're going to call that mass 1. We refer to mass 1 a couple of times in the lab. And looking at what's happening here, okay, so we'll just call that mass 1. And we'll call the cart mass 2. So, every single time we do the lab, we're going to take a weight off of mass 1 and put it onto mass 2. The total weight is going to stay the same. We're never going to set a weight on the lab table. So we're always reducing mass 1 and adding to mass 2. Now, as far as what's happening goes, we have on this mass a force of gravity acting down. It's pulling that mass down, which in turn pulls mass 2. To calculate this force of gravity, and this is step number 5 on your notes, to calculate that force of gravity, we're going to take mass 1, whatever it is, and multiply it by the acceleration due to gravity. Now, some notes on this. Mass 1 must be in kilograms. Some people were having some issues with this. 1 kilogram is 1,000 grams. So if you have 20 grams, and I want to get that into kilograms, we say, okay, 1,000 grams, 1 kilogram, leaves me with 0.02 kilograms. Grams on top, grams on bottom. This is what I need. Keep that in mind. The other thing is this G. We've used G before. It is the acceleration due to gravity. Not the acceleration that the object has, but the acceleration due to gravity. So that's always, in lab, going to be 9.8 meters per second squared. If we're not in lab, yeah, we can use 10. But in lab, since it's a real-world situation, we want 9.8. This is the force that goes into the table on your lab. This is how you calculate that force. This is the force that's pulling down. So, the big idea here with the lab is that we are decreasing the force on the system every time by removing some mass from the hanger and putting it on the car. We're leaving the total mass of the system the same. And what we want to do is to create a graph of our force on the y-axis and our acceleration on the x-axis. And so we're going to reduce our force, and we should see our acceleration reduce every time. So in your lab notebook, you're going to make a graph with the best fit line. You're going to find the slope of that best fit line, and you're going to answer some questions about what that best fit line might refer to. Now, as you're doing this, I will say that this is a Newton's second law lab. And if you recall, Newton's second law is the sum of our forces equals mass times acceleration. That may or may not help you as you go through questions. Now, a couple things that, to continue looking at stuff, we're going to look at calculating the acceleration. So I've got some pictures here. This one is what you should have on your lab quest after you send the thing. Now, on our velocity versus time graph, we have this wonderful little bit of constantly changing velocity, or constant acceleration. So, what we want to do is calculate that slope. So, on your little lab quest, you're just going to tap a spot. And what the lab quest is going to do is tell you the velocity at that spot and the time at which it occurred. So, we're going to have velocity 1 and time 1 here. We're going to click on a different spot a little bit further up, and we'll get the velocity at that spot, velocity 2, and the time at that spot, time 2. So if we want the acceleration, we know that from the slope of a velocity versus time graph, we get acceleration. That's ugly. I apologize for that. So the acceleration is the slope of v versus time. And as we recall, anytime we want to find a slope, m equals y2 minus y1 over x2 minus x1. So in this case, our slope is acceleration. y2 is velocity 2 minus velocity 1 over time 2 minus time 1. So for what we have, oh, made a little mistake there. Velocity 1. So for what we have, velocity 2 is 0.625 minus velocity 1, which is 0.225, divided by time 2, 3.35. Yeah, 3.35 minus time 1, 2.25. So we do a little calculator stuff, and we get 0.4 meters per second, because we just subtracted velocities, divided by 1.1 seconds. That leaves me with an acceleration of 0.36 meters per second squared. That's how I get the acceleration for one run. Tap those 2 points, get those values, calculate it out. You should have all that information down. You're going to do that 4 times. So after the first run, you're going to remove one weight from the weight hanger, mass 1, and put it on top of the cart, mass 2. You're going to find your new values for mass 1 and mass 2. You're going to write those values here. So let's just remember that mass 1 is the hanger. Mass 1 is the hanger. And that mass 2 is the cart plus any mass that we've put on it. Now, it's going to be good to remember that the cart all by itself has a mass of 1 kilogram. So for mass 2, you're going to have something like, and it may not be exactly this, but 1 kilogram, 1.02 kilograms, 1.07 kilograms. And then, let's just say 1.13 kilograms. Because we added a 20 gram mass here. And then we added a 50 gram mass. And we added another 50. Oh, did that backwards. Let's say we added 60 grams. You didn't have that option. That's the cart. So in here, you're going to start off with something small, like 0.19 kilograms. And then since we added 20 to mass 2, we subtracted 20 from this. So 0.17 kilograms. And then we added 50 to mass 2, so this went down, and I have 0.12 kilograms. And it goes down by 6, so I have 0.06 kilograms. Alright? Either way we do this, our total mass stays the same. The total mass of the system is still the whole time 1.19 kilograms because we always took it from the hanger, put it on the cart. The acceleration we get from the last slide, you just put it in there. And the force we talked about on the first slide, that's mass 1 times 9.8 meters per second squared. After you do all this, it's time to make your graph. So that's a graph of force on the y-axis versus acceleration on the x-axis. And I'll make a note of that. Force on the y, acceleration on the x. After you do your graph, you do your best fit line plus the slope of the best fit line. Show your calculations for your slope on that one page in your lab notebook where the graph goes. Be sure to take up as much space as you can. Third thing you do is answer questions. And then the fourth thing that you're going to do is write your conclusion. And I've included what I want in your conclusion on our lab instructions. And remember, this is one of 3 labs that we're doing for this unit, and we're going to take a lab quiz after we've done all 3. That lab quiz is going to have questions like copy down the table from lab 1, write the conclusion for lab 1, write the conclusion for lab 2. What was the slope for your graph in lab 2? I want you to use your lab notebook on that. This is how I'm going to check that you're doing everything I need you to do in the lab notebook. I'm only going to give you 20 minutes for the quiz, which means you're only going to have time to copy it out of your lab notebook. So please get this done as soon as possible. Thanks.